Hi students, in this video we are going to learn about three important properties of Laplace transform. That is to find the Laplace transform of functions that are multiplied by t, divided by t and integration with respect to t. The first property we are going to learn is multiplication by t. If L of f of t is equal to f of s, then L of t into f of t will be minus d by ds of f of s. That is, the Laplace transform of multiplication by t and t square is obtained by using differentiation with respect to s. Suppose if it is multiplied with t power 1, then one time differentiation we have to do, multiplied with negative. If it is multiplied with t square, we have to go for 2 times differentiation with positive. Like for odd numbers, we will be having a multiplication with the negative sign. For even power, we will be having positive. More generally, L of t power n into f of t will be equal to minus 1 whole power n into d power n by ds power n into f of s. So more t in time domain, more differentiation in s domain we have to do. Now let us go for solving some problems involving multiplication by t. Let us go for finding what is Laplace transform of t into cos 3t. So here the given function is multiplied with a t. Whenever the given function is multiplied with t, it indicates that we have to differentiate. Now here power of t is 1. So we will be having a negative sign. D by ds of, it is L of f of t. So here the function is actually cos t, we got it. This is our f of t. So we'll be having, this is equal to minus d by ds of L of cos 3t. We know that what is L of cos 3t formula is, L of cos 3t is equal to formula, it is s divided by s square plus 3 square, otherwise s square plus 9. So here we'll be having, it is minus d by ds of s divided by s square plus 9. So we have to differentiate this once with respect to s. So here we have to go with u by v rule. So what is differentiation of u by v? We will be having it as v square v du minus u dv. So this quotient rule let us apply here. The denominator will be s square plus 9 the whole square. Keep s square plus 9 as such. The differentiation of the numerator s will be with respect to s is 1 minus keep s as such. Differentiation of the denominator will be 2s. So this minus sign is common for both the terms. So go for a simplification of this one. So it is s square plus 9 minus 2s square. So this you'll be having a negative s square. And outside a negative sign is there. So the final answer will be s square minus 9 divided by s square plus 9 the whole square. Now let us go for the next problem. To find Laplace transform of t into e power minus t into sin t. So here the function sin t is multiplied with two things, that is t and e power minus t. For e to the power of minus t, we have to use shifting property. And for multiplication by t, we have to do a differentiation. So that means here we will be finding first of all what is L of t sin t. What is shifting property? Whenever the given function is multiplied with e power minus t, then Laplace transform of t sin t, after finding that we have to shift our s to s plus 1. For this multiplication by a t, we will go with one time differentiation of L of sin t, and then finally we will substitute our s to s plus 1. So what is L of sin t? L of sin t is nothing else. According to our formula, it will be 1 by s square plus 1. Then you shift your s to s plus 1. So here what is differentiation of 1 by x? Differentiation of 1 by x will be minus 1 by x square. So here you will be having minus of minus 1 divided by s square plus 1 the whole square into, it is a chain rule. Now if we differentiate s square, we will be having a 2s. Then we shift our s to s plus 1. So this minus will become plus. The final answer will be 2 times s plus 1 divided by s plus 1 the whole square plus 1 the whole square. Now let us go for one more problem. Let us go for finding what is L of t square into sin t. So here very clearly our given function is multiplied with t square. T square means we have to differentiate 2 times. So it is positive d square by ds square of L of sin t. We know what is L of sin t is. It is d square by ds square into 1 divided by s square plus 1. So 2 times differentiated. First one time differentiation will be as what we saw in the previous problem. Differentiation of 1 by x will be minus 1 by s square. So we'll be having minus 1 by s square plus 1 the whole square into differentiation of s square will be 2s. So one more time this one we have to differentiate. Apply the quotient rule. So we'll be having s square plus 1 the whole to the power of 4. Then keep s square plus 1 the whole square as such. And what is differentiation of minus 2s? It will be minus 2, then minus, keep this minus 2s as such. Differentiation of s square plus 1 the whole square. First of all, we have to apply the power rule. So it is 2 times s square plus 1. Then what is differentiation of s square will be? It is into 2s. So very clearly we can cancel one s square plus 1 in the numerator and the denominator. Otherwise we can take common and we can cancel it down. So that we'll be having s square plus 1 into minus 2. Here it will be minus into minus will be plus. Here 2, 4 and 8. So it is 8s square divided by s square plus 1 the whole cube. So on simplification, here we'll be having 6s square minus 2 divided by s square plus 1 the whole cube. So to conclude this property, whenever the given function is multiplied with t, then we have to differentiate the given function with respect to s. If shifting is involved there, we can shift it. Now let us go for the next property. The next property is division by t. The Laplace transform we have to find for a function when it's divided by t. Now we have to use integration property. That is integration s to infinity L of f of t ds. So by t means it indicates integration. So divide by t in time domain, integration in the s domain. For this property to be valid, the function must satisfy the condition limit t approaches 0 f of t by t must be finite. So before dividing by t, always check the behavior at t is equal to 0. The function explodes to infinity, Laplace transform refuses to work. So let us go for some problems in this one. Find Laplace transform of 1 minus, it is cos 2t divided by t. So here the given function is divided by t. So we have to go for an integration. So according to the property, it will be integration s to infinity. It is Laplace transform of 1 minus cos 2t into ds. So which is equal to, it is integration s to infinity L of 1 minus L of cos 2t into ds, which is equal to integration s to infinity. What is L of 1? It is 1 by s. minus what is L of cos 2t? It is s divided by s square plus 4 into ds. So we have to integrate this one. And very clearly we know that integration of 1 by x into dx is equal to log x. And whenever the differentiation of the denominator is in the numerator, we will go for log. That means for both this integration, I will be getting the answer as a log function. So here the integration of 1 by s will be log s. Similarly here, what is differentiation of s square? It is 2s. But here 2 is not there. So you can multiply and divide it by 2. So I can write it as half a times log of s square plus 4. And then the limit will be from s to infinity. So if you can pick 1 by 2 commonly outside, it is half a times, I'm taking an LCM, it is 2 log s minus log of s square plus 4, and the limits are from s to infinity. Further, you know that this 2 when it comes using the log property, m log n will be log n to the power of m. We can write this as half a times log s square minus log of s square plus 4, and the limit will be from s to infinity. What is log m minus log n? It will be half a times, it is log m by n, that is s square divided by s square plus 4, and the limit will be from s to infinity. To apply the infinity, if I can get an 1 by infinity, the term will vanish out. So take a s square commonly outside from the denominator. We'll be having s square divided by s square into, it is 1 plus 4 by s square, and the limit will be from s to infinity. So if we can apply that limit there, we'll be getting half a times, it will be log of it is 1 divided by 1 plus 4 by s square, and the limit will be from s to infinity. So if we substitute infinity here, this term will vanish out. So we'll be getting half a times log 1. And when we substitute that s, it will be the original function itself will come. So I can write that as log of s square divided by s square plus 4. So log 1 will be 0. So the final answer will be half a times log of s square, minus is there, minus log of s square by s square plus 4, or otherwise even we can write this as log of half a times log of s square plus 4 by s square. For a negative sign, we can reciprocate the given answer. Let us try one more problem. Finding Laplace transform of 1 minus e power t divided by t. So here again the given function is divided by t. So we will integrate from s to infinity L of 1 minus e power t into ds. So what is L of 1? L of 1 will be 1 by s, and L of e power t will be 1 by s minus 1 into ds. Very clearly here, again the same function. Integration of 1 by x into dx will be, it is log x. So here the integration will be log s minus log of s minus 1. And the limit will be from s to infinity. So what is log m minus log n? It is log s divided by s minus 1. The limit will be from s to infinity. So we take s commonly outside from the denominator. It will be 1 minus 1 by s. And then let us substitute the limits. 1 by infinity, the term will vanish, and we'll be having log 1 minus log s, means the original function, that is log s divided by s minus 1 will come as such. So log 1 will be 0. The answer will be minus log of s divided by s minus 1, or otherwise we can reciprocate as log of s minus 1 divided by s. Thank you.